Okay, good evening, everyone. I hope you had a wonderful day today. Thank you for all being here. It is quite a late hour already. Welcome to my talk about sentiment analysis with Apache Spark. Since it's my first time here at DevVox, I'm going to very quickly introduce myself. My name is Niels. I work and live in the Netherlands. I live in Maarsen, a small town close to Utrecht, together with my daughters and my girlfriend. And I work for a very small, 30 people, but very cool consulting company called J-Driven. Like the name sort of implies, we specialize in Java consulting. Work together with really fun and smart guys. If you're looking for a job, please come to us because we need more people. What do I do? My daily day-to-day job is working at a small fintech startup at ING, the biggest Dutch bank. As you can see, we sort of check all the hipster boxes in when it comes to our stack. It's basically Spring Boot microservices backed by Cassandra. We do all kinds of cool data science stuff that runs on Apache Spark. And I've been working there for about a year now, and this is also where I basically ran into Apache Spark and started finding all kinds of cool stuff to do with it, like porting genetic algorithms onto Spark and stuff like that. So let's start with sentiment analysis. What is sentiment analysis? It's quite a big word for I'd say a pretty small thing. It's not complex, but in essence, what you're doing is trying to figure out if you have pieces of text, and that can be documents or tweets or anything else, try to figure out if it's a positive or negative text. So why do you want to do this? Well, tweets are actually a great way if you know if they're positive or negative, to see if how your customers respond to changes in your product. And there's a lot of vendors who do something like that, especially for tweets. So what they're doing basically is figuring out if pieces of text that are sort of like fixed list, like a word like happy, that's a positive word in most cases, or this product is horrible. Horrible is in most cases a negative word, and try to extract a meaning from that. So I'm going to first show you a type of thing that you can do with it, and later I'm going to explain how it works. So I need to find something that has a lot of text and has people kind of divided on the subject. So, and it's gone. And there it is again. So this is the, I hope you can, it's going too fast to read actually. This is the Twitter feed. This is a small Spring Boot service with an Angular front end. You can see my incredible CSS skills here. So what it does is analyze all the tweets that are coming past that have the word election in it. Now, we're very close to the American elections coming to a close, so as you can imagine, the sentiments are quite divided on it. The yellow ones are neutral comments. The green ones with the happy face are the ones that have more positive words than negative words, and the negative ones are the inverse. So, how does this sentiment analysis actually work? I opted for a very simple approach. This is a word list that is extracted from a number of different sources. You have a very cool sentiment analysis course on Coursera. There's also something that's called the Sentinet word list, also pretty well known. And it basically is a long list of positive and negative words. And what it does is count them and sum them, and you end up with a score. Of course, this doesn't take into account inversions like not. I mean, I'm not happy is probably not positive. But for actually stuff like tweets, this works better than trying to do actual natural language processing, because natural language processing is actually very, very hard. There's all kinds of inversions and inversions that are a certain distance from the word you're trying to figure out. So I opted for a very simple approach, which works quite well for tweets and also for the next bit that I'm going to show. So the next bit, of course, is Apache Spark. So who of you have worked with Spark? Very few. I'm really happy to see that, so that I can actually probably tell you something new. So Spark is a framework library from the Apache Foundation, and what it does for you is make it easier to parallelize number crunching. Does anyone of you use Java 8 in day-to-day production? Okay, really cool to see. Do you guys use the Streams API? The new Streams API? Okay, cool. Then if you use the Streams API, this will look really, really familiar to you. This is also sort of the goal of Spark, is to make it quite easy to get started with it, giving you a bit more flexibility than the old map you use. I'm not saying that programming Spark is easy, because there's a lot of gotchas and pitfalls, and I think the talk after me is going to go a lot deeper into that, but it's really easy to get started with. So we want to do something with Spark, but of course a little bit of data is not very interesting. We want a lot of data. So I don't know, does anyone of you use Reddit? Yeah. Do people waste way too much time on it? Or am I the only one? Yeah, okay, cool. I'm not the only one. Awesome. A while ago, somebody downloaded all of Reddit. It's a huge data set. It's a terabyte compressed of text, basically. So I downloaded the entire data set on my server, and I figured, well, let's get started with it. One small problem. This laptop is a really awesome Apple. It has an SSD, but it will never fit 1 terabyte, and so I had to take a little extract. So I used just 1 month of JSON data. It's still 5 gigabytes compressed, so you can imagine how busy that site is, and did my analysis with that. So I'm going to actually do some live programming. It's my first time, so I don't hope it all comes crashing down. Oh, that's after the next one. Alrighty. Let's switch to this one. Okay. So Spark. Basically, if you want to get started with Spark, you add a Maven dependency, and then you have a Spark library, and you can immediately start using it in your development environment. And this is what I really like about projects, and if anyone of you makes software, please do this for me as a developer. Have me test it in my EDA. That's so much more awesome than having to create something like a Zookeeper cluster just to be able to run your software, for example. Okay, I start with a Spark context. This is basically sort of the configuration, and because I'm telling it here, connect to master local. The master is where your work is pushed, and if you say local, and in this case I told it to use one thread. If you want to know why, come to me after. It actually spins up a local Spark cluster for you that you can immediately use and connect against and deploy your code on. So this is actually the big one, the big file. So I start with Spark context.text file, and this is actually what allows you to read a text file. You see here that's actually a bzipped file, but Spark can handle text files, directories, bzipped files, etc. for you. It's really awesome, easy to get started with. So let's take just the first 25, because this is the 5 gigabyte one, and do and this actually returns a list. So this is where you actually pull data from your Cassandra cluster into a list in your local driver. And for each system, that's it. Yes. Okay. So now it spins up actually the cluster. I disabled most of the logging output because it's a lot and it would drown out the output from my thing. Okay, so you here see the first 25 comments of February 2015 on Reddit. So, well, that's not very useful because now we just have strings. So let's first map them to a JSON object. Of course, I created this in advance. So it's a little utility function to comment. Which basically just uses Jackson, the mapping library, and map it to a Pojo, basically. And I can do the same thing. Take 25, and for each. Print. The downside of doing it locally is that you actually have to spin up the entire instance. So if you don't want this delay, you can actually download a Docker image or pull a Docker image and just run it on your machine, and then you can connect from your code to that machine and it will work exactly the same. Okay, so this is basically exactly the same thing, but what you're seeing is not the JSON, but it's the toString of the object that I created. So it has a time, and it's actually, it's actually January 2015. It's the subreddit. I hope it's sort of readable. The null is that it doesn't have a score yet, and then we have the text. So let's actually also do the scoring bit. Well, there are. We first have to clean up this mess a bit because there's a lot of deleted comments, and deleted comments don't have text, and without text you can't analyze it. So let's. Oops. We don't want the deleted ones. And again, map it. And I use a map function to go through the analyzer. Oh, I have to create the object first. Yes. And this is basically just a hash map. I'm not going to go into the code because it actually just loads that word list, push it into a hash map, and every word that comes in gets checked against that hash map. Right. So this is a map. So basically, what we did here, we first mapped it to an object, filtered out the deleted ones, run the analysis, which should assign a score, and then again take 25 and print them. So let's see if this works. It does. So instead of the null that you saw before, you now see that it assigned a score of a score object to all of the comments that were passed through the function. The cool thing is here, and you don't actually see it, but what happens is that this whole bit gets serialized by Spark and gets sent to a worker where it's actually executed. So one of the pitfalls is that all the pieces of both the classes that are code and the classes that are just transferring data, they have to be serializable because that's the mechanism that Spark uses to transfer your work to the worker. We're also really cool. If I replace this for this take 25 for collect, it will grab everything. This gives me some time to show you a pretty cool feature that Spark has included. Should be up now. I'll close this one. Yes, there it is. So what it's doing here is when you start Spark, it also spins up a console where you can keep an eye on the processes. and this will take a long time, and it hasn't even properly started yet. Later on, I'll not go too deep into it because I have only 15 minutes left, but you can sort of explore the complete graph that Spark builds for you here. And also, if you have a cluster, of course, you can have multiple jobs running at the same time, and you can inspect them, see how long they've been running, etc., etc. All right. But instead of collecting, I'm going to save an object file. And then we can move on to the next step. The object file is basically sort of a cache that you can sort of reuse. And I'm doing this here because I can't analyze this file here in parallel. I don't know if it's a bug. I think it is, but I can't use more than one core at the same time. So I prepared this and also prepared it with a smaller object file that's sort of like, I believe, 1/100th of this data set to be able to actually have it complete in time. So moving on to the next bit, I'm starting here with, instead of reading a text file, I'm reading basically the object file that I created in the previous example. And I have the same analyze comments here again, and I know that they're clean. So what I want to go and do here is present a list of all the top 1,000 subreddits and count the total, the negative, and the positive comments in those. So you can make percentages of those subreddits and show some neat statistics. So first let's start with this comments RDD. So it's a resilient distributed data set. It's basically sort of Spark's version of a stream. So instead of Java RDD, if you put stream there, you basically sort of have the same thing in Java land. So I'm going to do a pretty basic, I guess, a map reduce here. So I'm first going to map the comments to a tuple of subreddit key and account 1. So this is the comments. Tuple, I can't type anymore. No, come on. Get subreddits and 1. I'm going to reduce it by key. So you have the we get tuples, which are subreddits, for example, cats and 1, and you do a sort of typical map reduce function. So you first you then combine the results into a single pair, and this, because we're just counting the totals, it's a relatively simple sum. So Spark gives us only the value here, and I can just A plus B. So this sums up every unique, every tuple by key. And also want to filter it to remove the ones that are the small subreddits. We have a very long tail of very infrequently used ones. I want to remove that as soon as possible to speed up the process a bit. So you see here the wonders over tuples. You get just 1 and 2. So this is Java pair RDD. Integer totals. Okay, so this one, this is just the total. So we have the total sum of all the count of comments in these subreddits. But we also want, of course, the positive ones. I'm going to do basically the exact same thing. I'm just going to copy paste it. But call it positive. And first filter only the positive ones. Get sentiment positive. So this will give me only the positive ones. and I also want the negative ones. Negative. Okay, but as you can see here, we now have 3 completely separate streams. And of course, if we want to have like a positive percentage, we need to combine them. And this is what join does. So when you have separate streams of pair RDDs, Spark can for you, based on the key of that pair, combine them basically into a key with a tuple of tuples. And we do that twice, so we have a key and a tuple of tuples inside a tuple with just a value. And I'm not going to, I'll start with, so let's start with positive first, because positive join. So basically we now end up with one RDD, one stream with all the information combined. Cool, but of course, and I'm going to cheat a bit because this part isn't fun. This is the oneness of tuples inside tuples, and yeah, it's a bit of sort of the horrible bit of having to work with them. There we go. So what? Oh, I think I missed a few. Yeah. You know what? I'm going to just grab the entire stuff to make sure I don't make any mistakes. Fix this one, and I'll explain it what is actually happening here. Okay, so I have joined the negative and the positive ones, but I want to have the top 1,000. I don't want to have the entire list. I just want to have the top 1,000. So I have to. I want to sort them, and I want to actually use Spark for this, and not my local machine to sort them, because these data sets can be pretty big. But the way, if you want to sort something in Spark, you actually have to sort them on the key. So what we have to do here is reverse the key, because you might remember we first had the subreddit and then the count. We're going to swap them, sort them by key, and this false is just that it's descending. And then we're basically going to map them back again to tuple 4, which has the subreddit totals, positive and negative counts. Take 25 and then out.println. Print them again. Okay, and I'm going to run this, and I hope it works. The local cluster has started, so this should be okay. So what you see here is that only when you do the bit where you draw the data back to your local machine. This is what take or collect does. Then it actually goes and deploys your task to the cluster and execute it. And you see here all the different stages that it has to go through to do all the calculations. It's a small set, but you still see it has to read through a ton of data. I only have 6 minutes left, so I'm not going to wait for it because it takes 2.5 minutes, unfortunately. So I'm going to continue the presentation to show you the actual results when I did this with the 5 gigabyte January, February 2015 data set. I'm going to stop it because it's responding very slow, because this actually does take 8 cores. And you probably can hear my laptop lifting off. Okay, it should cool down a bit now. So to resume what we did in the previous example, we have the analyzed comments. We have 3 different streams: the positive, the neutral, and the negative ones. Do the map reduce. We filter them to take down the data size a bit, and then we join, sort, and take. In this case, what I did, the first top 1,000. So the result of that 5 GB dataset, AskReddit is by far the busiest one. It has over 4 million comments in 1 month, and there's a bunch of other very big ones. If we look at the most positive subs, so basically sub is a subreddit or subject. Makeup Prediction is an incredibly positive sub, so if you want to have a good day, then this is the place to be. There's also some porn there, also very positive, and of course Pokemon. Who doesn't love Pokemon? Most negative subjects, news, world news, these kinds of subs can be quite negative. Also Europe is quite a negative sub. So people who have used Reddit probably see some familiar names in here. So this is all fun. This is it took me a bit of time. I also did some other stuff, but what I did not do yet is use all the data. And that's something I still want to do, but I will have to rent an AWS or a Google Compute Engine instance to run all the data. There's a lot of fun stuff I still want to do, like positivity over time, how positivity relates to the voting people do in different types of subs, stuff like that. So still a ton of stuff I can do. Well, for me, the conclusion, I'm a Java developer. I ran into Spark like a year ago, and I'm having a ton of fun with it, and we'll see all kinds of data sets that I want to analyze with it. Maybe it's just me, but I think it's fun. It's easy to sort of not use, get started with. There's quite a few gotchas, and of course, if you have a lot of data, it's a great fit. If you have not a lot of data, it's probably easier to just do it on your local machine. And when it comes to sentiment analysis, I think it's very underrated. There's a couple of vendors who do really cool stuff with sentiment analysis on Twitter, for example, but also Facebook. And I think it's a very good tool to use if you launch a product and it's gone past your beta customers into the wild, and then you don't know what happens anymore. So I think it's a great tool to look into it. Okay, that concludes my presentation. Anyone have any questions? Here at front first.
Yes, you mapped all positive and neutral first and then filtered. Could you have done the mapping first and then filtered?
No, it's...
mapped first and then split or copied in different streams and then filtered?
No, it's filtered on the reduced data set. So when you start out with all the individual comments, and then you end up, you map them to those pairs, and then you reduce them, and you don't have the individual comments anymore. So you don't have the individual negativity or positivity anymore either. You just have a list of, or basically a count for a certain subreddit. Anyone else? You? Can I give my opinion? I hope it's Hillary. The tweets are coming too fast for me to view all of them. I'm afraid. Anyone else? I have almost 1 minute left, so. I have been playing a bit with Scala myself, just pet projects, but I have not used Scala in combination with Spark yet. I think the answer will be yes, because there's a lot of Scala stuff you see in there, like the tuples, and I'm 100% sure that will be easier to use in Scala. Anyone else? Alrighty, okay. Thank you very much. It was a lot of fun. If you have any questions or want to play around with it, the project is up on GitHub. If you have any questions, just poke me on Twitter or on GitHub or whatever. So thank you very much for having me here, and it was a lot of fun. Thank you.